Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's webinar, Monitoring in a Virtual Data Center, brought to you by Ixia and Corville. My name is Keith Bromley. I work for Ixia and will be your moderator today. We have just a few announcements before we begin. This webcast is designed to be interactive between you and the presenters. Please feel free to ask questions at any time in the Q&A window. We have reserved time at the end of the webinar to address questions. The webcast console you are looking at can be completely customized. You can resize or move any of the windows that you have open. At the bottom of your audience console are multiple application widgets you can use. If you have any question during the webcast, you can click on the Q&A widget at the bottom and submit your question. Also, a copy of today's slide deck will be available post-webinar in the resource list widget that looks like a green folder at the bottom of your screen. A link to the on-demand version of this webcast will be sent to you approximately one day after this webinar. And finally, if you are experiencing any technical difficulties, please visit our webcast help guide by clicking the help button below the presentation window. It has a question mark icon and covers common technical issues. All right, let's get started. We want to thank you for attending a short webinar on virtualization technology. We feel that this is a very important topic for network visibility. With the proliferation of virtual technologies over the last 5 years, it has become increasingly important to understand and use these technologies to their fullest potential. Our presenters today are David Pham, Product Manager for Ixia, and Ken Jinks, Director of Product Management for Corville. Both of these speakers are experts in the topics of virtualization and network monitoring. Here's what we plan to cover today. We'll start with a virtualization overview and a network monitoring overview, just to give everybody a level set. Then we'll specifically talk about monitoring in virtual environments and focus on technology that's currently available to help you get the most data from your network in the most cost-efficient way. Before David and Ken begin, I'll set the stage here with a brief overview of virtualization, and then our main speakers will take over. As I stated earlier, this section is primarily designed to make sure everyone understands the basics of network virtualization technology. So let's get going. Here's a short summary of typical data center challenges. I'm sure everybody's familiar with these. Controlling costs is paramount, as data center managers are expected to continually add more equipment and then maintain that same equipment, most often without any additional staff. This has created a need that technology has been asked to solve. Fortunately, virtualization has been up to the task. Virtualization has been one of the clear technology success stories. Data center managers continue to invest in this technology. In fact, IDC states that in 2009, the tipping point was crossed where more virtual machines than physical hosts were being deployed. As you can see from the slide, there are many benefits that server virtualization has introduced to the data center. One of the main ones being cost reduction of physical hardware and the ease of spin-up of new virtual machines. Both of these have improved the economies of scale for data centers. Of course, no good deed goes unpunished. While virtualization has many benefits, it also has contributed a negative in that it created some blind spots in the data center. This comes about because most of the virtualized data center traffic never makes it to the top of the rack where it can be monitored. In fact, Gartner did a study on this and found that as much as 80% of the virtualized data center traffic fits into this category. This creates a huge blind spot because you can't monitor what you can't measure. In a perfect world, this might not be so bad, but unfortunately malware is a reality, and there are some malware variants like Crisis that target virtual servers. This necessitates the need for some sort of monitoring strategy in the virtual environment. Forrester conducted a study for Cisco. Their study validated concerns for virtualized data center deployments. As you can see here, Security is the top concern, with 52% of data center managers concerned about this topic. I've also circled two other concerns: complexity and compliance. These three areas are blind spots that have either been created or intensified by virtualization technology. But what do we really mean by blind spots, and what's the problem with them? This slide shows you the 4 key visibility points in a virtual network. Point number 1 isn't a problem. Since the data is transferred from the equipment in one rack to another, this gives the data center administrator an opportunity to use a physical tap to access the data. But for situations 2 through 4, there is no easy access with standard taps and monitoring tools. In the case of point 2, there is limited visibility within the server chassis. In case number 3, the traffic passes between VMs within the same physical host. And in case number 4, when VMs are moved, any access to the VM that might have been established is typically lost. Points 2 through 4 are what we mean when we talk about the opportunity for blind spots to exist. Traditional monitoring tools, like I said, just don't give you the access to this data. The next obvious question is, so what? Well, because of these 3 situations we just mentioned, there may be malware, VM performance problems, or other issues that you typically won't know about until you have an incident that often takes a while to identify, diagnose, and then remediate. All of this creates additional cost and attention from senior management and other groups, the kind of attention you probably don't want. Basically, hardware servers have now become software application files like .vmdk. Hackers can penetrate networks locally and now remotely. This makes it a lot easier for company information to be copied or stolen. In addition, you may have issues being able to demonstrate compliance to regulatory standards like SOX, PCI, and HIPAA because you can't get proper access to the data. This is another headache you probably don't want either. So let's look at the blind spots from the previous page in more detail. Security is a major issue. Malware-like crisis that I mentioned previously is real, and it can spread unnoticed. Virtualization by its nature is a multi-tenancy environment that allows the possibility for others to do lots of harm once they have access to the environment. Promiscuous mode exacerbates the multi-tenancy issue by making it easier to get that unauthorized access. Software patching is another concern. It's just as important in the virtualized environment as it is in the physical environment. Lack of proper patching leaves security holes for hacktivists to exploit. A virtual tap will give you the access you need so that the virtual data center can forward the data onto your security monitoring tools and proactively monitor your network. According to Gartner, for every 25% increase in functionality of a system, there is a 100% increase in complexity. Not a comforting thought, is it? Unfortunately, it's a reality, and you'll want solutions that are easy to install and maintain but still give you the access to the VMs you need. Security management also becomes more complex when dealing with dynamic network deployments. However, simplification from the virtual tab adds effectiveness with shorter detection and responsive times to network anomalies. Complexity is also exacerbated by the plethora of applications and devices entering the network daily. All of these components add complexity to your security and monitoring policies. Without the proper access to the VMs, you'll find it very difficult to perform any meaningful trend analysis. Consistent monitoring policies are another good practice that save time and money. By adding a virtual tap, you get access to similar types of data as that on the physical network. Once you're at this step, it's fairly easy. You can extend the same security monitoring policies you're using on your physical network into the virtual systems. This also eliminates the need to manage different policies for virtual and physical server configurations. At the same time, this makes it easier to achieve, track, and demonstrate compliance requirements across your network. All the requisite data can be forwarded to one set of tools responsible for the regulatory compliance function. You now have everything you need in one place. By implementing a visibility architecture, especially one that uses virtual taps, you'll be able to get the proper access to your data center you need and be able to export that data to your packet broker and monitoring tools. Let's change gears and do a level set on network monitoring now. So I'm going to hand things over to David Pham.
Well, thanks for the overview, Keith. So let's take a step back in time and look where the big picture where it all started. Back in the late 90s, the internet was transforming communications before our very own eyes. Monitoring started off as a very simple concept. No longer was IT managing office infrastructure like copiers and printers, but began expanding into a bigger role. They were taking on a whole new communications framework. The focus was now building out the networking infrastructure and getting everyone connected while being able to monitor, troubleshoot, and maintain uptime and availability. This need would we like to pinpoint where the birth of the NOC, or Network Operations Center, was formed and created. Once IT had a solid infrastructure in place, we also saw an explosion in applications, and an explosion in data was created by those applications running within the network. The focus then shifted, and the hot topic then became all about managing performance and data security. It became a new priority to manage performance and the applications running within the network. Because of this flood of new data traversing the production core switches, Phase 2 came along for IT staff, where we saw the need to form a new Security Operations Center, which allowed system administrators the ability to manage security and the privacy of their data. And now what we see is changed user expectations. My expectations have changed. Your expectations have changed. Users' expectations have changed dramatically over the past 5 years. We all now have smartphones, tablets, laptops, and multiple PCs at home for our families. We use tens, if not hundreds, of applications every single day. We just expect it to work no matter where we are or what device we're using. We expect immediate access to all the applications we've grown to love or even hate with a simple click of a button. As technology changes, IT's focus must adapt and embrace the changing times. Now it's all about the end user. How does IT deliver on these user expectations? Not only for the user base as a whole, but for every single individual user using each and every application. How does IT monitor and ensure that they're delivering their service of SLAs? How do they monitor and maintain context-aware, and most specifically, application-aware visibility? Over the last 20 years, what we've seen is the introduction of tools, and even more tools to provide monitoring, visibility, and security. It all started with a few simple network management tools like NetCool, HP OpenView, and WhatsUp Gold. Then we saw the introduction of tools to manage the network and application performance, tools like SolarWinds and Wildpackets. Then came security monitoring tools such as ArcSight Security, Information and Event Management, or SIEM for short. And now recently, we have a huge wave of products focused on managing user end and customer experiences from IBM TLIF and Splunk, for example. This need has created a new network challenge. IT organizations are involved in trying to manage and monitor what connects to their network, from application and network performance to security to end user experience. All of the tools they need to access the data on the network. Well, actually, in fact, many of the tools on the network provide better insight when they're collectively getting data from a centralized data center, the DMZ, the network core, and throughout different remote office locations. And if you can see on the right here, there's a lot of different tools needing access to the network and visibility to either specific parts of the network or all the network. So what's the problem? The problem is that many of these tools have difficulty getting onto the network and getting the visibility that they need. Why? Because it's due to one of two issues. There's not enough network access ports, and there's not enough tool capacities on the appliances. Or there's not enough span ports and tap ports available on the tools for this support. And lastly, if there's not enough network access, the tools don't have the capacity to absorb and analyze the packets from the entire network. That means that the IT organizations can't properly manage what they're trying to manage and control. So what do you need to solve this problem? Most of the organizations that we meet are just looking for complete end-to-end visibility. That means they need tool access, and not just to any point in the network, but every point in the network. They're also looking for a solution that's scalable and flexible, one that will scale to match the size of their network, and most importantly, it needs to be easy to manage and automate. They're used to sophisticated management tools, so they want an enterprise-grade management solution. But most of all, they need control. They want the ability to control the aggregated data or filter the data out and the metadata before it gets to the endpoint tool. At the end of the day, no one has an infinite budget. Value provides them the ability to reduce the overall cost and make their visibility solutions more efficient. Visibility architecture is the way to solve these needs. The basis of visibility architecture starts with creating a plan. Instead of just adding components as you need at sporadic intervals, let's take a step back and look at the holistic view of where you are and what you want to achieve. One of the simplest and most important things is that you need to save time, money, and energy in the long run. The solution architecture starts with the access layer, and then onto the network packet broker layer. Do you need inline detection or out-of-band monitoring solutions? These products form the infrastructure part of the visibility architecture and focus on the layer 2 to layer 4 of the OSI model. Then there's components that make up the intelligence layer from the visibility architecture. This provides the application and session-aware visibility. These are the layer 7 application components that provide high-value contextual information about what's actually happening within your network. For example, you need to understand and maximize the efficiency of the current monitoring tools to reduce operating costs. You need to gather rich data about users and applications in order to offer better quality assurance for your users. And lastly, you need to provide fast, easy-to-use capabilities to check security and performance problems. Lastly, the management component provides total control of the entire visibility architecture. Everything from global management, policy configuration management, and even data center automation and management. Engineering flexible network components will be a determining factor in how well your network performs and scales out. While we're on the topic of visibility architecture, I want you to show you this slide here that puts everything together. I'll elaborate a little more in the next session, but this slide here shows that it's optimized to get access across east to west traffic within a specific hypervisor. So how do we solve this problem? Customers have physical monitoring tools that need to access the east to west traffic in the virtual environments. We have a virtual tap that installs directly into the hypervisor kernel stack that brings the same access into any existing endpoint tool. This integrated single solution can aggregate traffic from the virtual environment, filter out traffic of interest to any monitoring tool of choice. The monitoring tools now get a single view of the end-to-end data from the applications running within the VMs and the network cloud data across the network and to the users at the end of the edge of the network. You can manage this entire solution as a whole, from the access layer to the control layer and all the way up to the application layer. So we've talked about virtualization and we talked about the visibility architecture. So let's put it all together. As you can see here, traffic in the traditional environment actually goes inbound and outbound. But with virtualization, the adoption of virtual switching, traffic now travels east to west, as you can see here. Now, when the communication happens from VM to VM, your physical core switches and network performance monitoring tools cannot see those transactions, hence creating the network blind spot, as you can see in the bottom left. In most best practices, security and IT administrators would consolidate VMs and applications that communicate with each other all in the same hypervisor for one of two reasons. It reduces the network latency when the packets need to travel from host to host or even to data center to data center. And number two, it increases efficiency as it reduces the amount of traffic and network packets that hits the core switch for routing. On my earlier slides, technology changes and customers adopt new ways to deploy their applications and networks. We're also right beside them to provide the new solutions to simplify the way they manage and get visibility to the data center. Phantom Vtap is a software solution that provides IT and security administrators the ability to extract and mirror network packets from their virtualized data centers and virtual switching. This allows IT teams to gain better visibility, pinpoint performance issues, and improve overall security across their virtual infrastructure. This solution here sits on a hypervisor kernel stack, as you can see in this diagram, in between the virtual machine and the virtual switch. What that means is that we never install any services or agents at the VM or application layer, allowing you to retain 100% of the system resources. It also doesn't require your vSwitch to go into span or promiscuous mode, hence allowing you to keep the vSwitch running at optimal performance. This slide here explains the out-of-band solution. And when I say out-of-band, it means it never interferes with the network packet flow as it leaves the virtual NIC to the virtual switch. Traffic is only mirrored from predefined policies and captures only the traffic of interest to forward it out a separate data path from the production VM port group. And this maximizes the network throughput of your application traffic and virtual switching architecture. Another reason to have the segregated data paths for mirrored traffic is that in multi-tenancy environments and hosting environments, you can never risk or compromise having sensitive data and networks crossing each other due to compliance and security concerns. Or even within the same company, different departments have different security policies. You never want data and information passing between engineering to sales to HR to marketing, for example. VMs and applications are constantly being vMotion or migrated from host to host to data center to data center for a couple of reasons. You want to maximize resource sharing and efficiency. You need to shut down servers for hardware upgrades and maintenance. So a good modern solution needs to have the ability to have full visibility across the vMotion and be aware that the VMs are being moved to host, and most importantly, never tied to a specific hypervisor. Phantom Btap follows the UUID of the VM, so it provides 100% visibility throughout the migration. If you have a policy in place from a source location that mirrors VoIP traffic, you'll continue to have that same VoIP visibility on a new destination host. Other solutions may adopt whatever policy might be in place at the new host level or virtual switch level. And other solutions may lose visibility altogether if there's not a right security policy enforced on the destination host. The visibility architecture provides a seamless diversion of packet data into monitoring tools. Most IT admins are already familiar with this concept from the physical networks. Physical taps allow the ability to insert an access point where they can replicate the traffic from the core switch. This traffic is then sent to a network packet broker for additional filtering, load balancing, deduplication, or regeneration and aggregation. The data is then passed to various monitoring tools that perform analytics for security, performance, application monitoring, compliance, or any other SLA agreements you have with the customer. And this diagram shows the virtual tap, where it's a solution that gets inserted into the access layer in your virtual data center that allows you to get the same access into the virtual switch and do exactly what the physical tap does for the physical network. And that is, of course, to provide another data source to your tools to gain visibility into your network again. And also, most importantly, it allows you to increase the ROI of existing tools that you've already made investments in on your physical monitoring environment. We don't require you to buy new tools or software probes to get the visibility into your virtual architecture. So now that you're able to see the end-to-end monitoring solution that fills out each of the areas that we talked on defined in the visibility architecture, the access layer sends the traffic from the network packets to your network to the network packet broker control layer. The traffic is then filtered accordingly to predefined criteria to the monitoring layer where the tools can focus on doing what they do best, and that is provide you with the intelligence, trends, and deep analytics to keep your business and operations running efficiently and secure. I just want to go over some of the key features again about what a virtual tap and Phantom has to offer. One of the key things is that it's a kernel level installation that installs at the hypervisor stack. And what that means is that we never install any services or agents on the VM or application layer. There's no monitoring probe or VM that needs to get installed on the hypervisor host level as well. and it gives you 100% of the system resources. We never have to sacrifice virtual CPU, virtual RAM, or storage from your virtual machines and applications. It's also very important that we have the ability to give you the ability to define custom filtering policies. You can create capture policies based on layer 2 to layer 4 headers. And what this means is that it optimizes your endpoint tools by only receiving traffic of interest. In virtualized environments and blade servers, you can easily oversaturate and oversubscribe your monitoring tools and with dropping packets and unable to look at the traffic of interest. Another key thing is that it's virtual switch agnostic as it sits at the kernel level. We're able to support all the different virtual switching fabrics, the virtual standard switch, the virtual distributed switch, and the Cisco Nexus 1000V, for example, if you need to adopt third-party virtual switching. And most importantly, you never have to enable promiscuous mode or span ports on the virtual switch. And of course, being tool agnostic, we're able to leverage any tool that you already have and adopt any current monitoring policies that you have for your physical environments. IT staff and security admins can continue to use what they're familiar with and continue to use the policies that they understand and to be able to react on. So with the complexities of 10, 40, 100 gig networks, there's simply too much traffic to account for in your physical network, and now you have to account for the traffic from your virtual network. And also with a blind spot, you probably didn't even know that even existed. But our access solutions are plugged in each corner of your network and aggregated to any NPB, where we'll allow you to have the ease of management to send traffic of interest to any tool of choice, an IDS, an APM, and in this case, a Corvo appliance to provide you more meaningful traffic trends and statistics. And here, I'll hand it off to Ken, who will give you more insight into the Corvo appliances and what we do with the traffic once we access it from the core switch.
Okay, great. Thanks, David. So I'm conscious that a lot of people aren't quite aware who Corvo is. So this is a slide that kind of succinctly summarizes what we do. And so when we say streaming analytics to make network data accessible, by network data we mean the packets on the wire and the payload that's inside those packets. It's like this is a very, so you could consider authoritative, independent, and a very, very rich source of information about your business, about your applications, about your infrastructure and its performance. However, this is typically large in volume and can be difficult to access, which is why we're here today and presenting with Ixia. But what we want to do with this network data is make it accessible. We want to make it searchable. We want to make it consumable, and we want to do this for the business, for the application ops team, and for the network infrastructure team. And I'll show you the next slide here is a bit of visualization of what I'm talking about. So here you can see Corvo is instrumenting the network data, right? And from here, and this instrumentation layer is why we're presenting with Ixia, which offers a scalable and cost-effective way to get to this network data in both physical environments and in virtual environments. So it's equally valuable data from either environment. And this is, it's independent, it's authoritative, and it gets you all activity from all clients or all applications on the network. It gets you all transactions, all interactions. It's essentially, from the network, there's nowhere to hide. And this information, as you can see, as we analyze it and bubble it up, it can be useful at the business layer to report actual customer transactions. It can be useful in the operational layer to report database transaction performance or storage performance. And finally, it's extremely useful to report your client's experience and what your client is, whether they're internal or external clients, what's their experience as they try to interact with your applications and your business and the service that you're offering. So, and I have a great example coming up later. I'm going to talk you through a use case of exactly how that works. But before we jump into that, let me just take you through how does Corvo do this. So we're an appliance, right? It's a piece of hardware you plug into your network with Ethernet ports, and you just plug it in. through Ixia as we've been discussing today. You plug it in, and it starts to discover all applications that are flowing in the network or in the virtual network between maybe an application server and a database server or whatever is virtualized. And from there we discover whether it's VoIP or storage or database or HTTP or web services. We have over 400 protocols that we can discover, and out of that we start running our analytics. And everything we do is in real time. And based on what we discover, we produce the analytics of interest. So if we're discovering database, producing things like database transaction times or database insert errors or analytics related to database is what comes out for the discovered database transactions. And for storage, it might be authentication errors or media errors or, again, storage response times. And for HTTP, it's different again. Maybe you're going to see 404 errors or actual customer transactions. Whatever the analytics that make sense for the application are what Qorvo starts to report at that point. And then from that reporting, which can be done in real time and published to dashboards, the other really powerful information that you can get out of it is indexed global searchable data. So if you can imagine, we have customers with thousands of servers and hundreds of sites, and you choose to instrument all these points to be able to go to one point and type in and search for maybe a VoIP extension or search for a URL that may be accessed from multiple points, or search for a file that's being used from an NFS server. If you can globally search for that and find wherever it is throughout your instrumented infrastructure, the power of the information in your network data is now all of a sudden accessible and consumable and searchable like never before. And finally, although we stream it ourselves to our own real-time data, our own real-time dashboards, we also stream it externally to other systems like Hadoop, for example, where if you're getting all transactions from your client base, you can put that in Hadoop and manipulate it in ways that are interesting to the business and get out business-level reports. There's a lot of power. And all that's coming from the payload in your network data. And other customers of ours are streaming it to Splunk, for example, which has its own indexing capabilities and its own dashboarding capabilities that maybe people find more useful than the way Qorvo chooses to present it. Either way, it's getting that information out of your network data, manipulating it, summarizing it, and then streaming it north to other systems that are of interest and that can consume it in really, really powerful ways. So here, what I have is an example that I want to take you through of an actual customer environment that we're deployed in, where they're actually running a retail banking service. And the service is made up of clearly users out there, in their homes or wherever, accessing over the network, over the internet, coming in through network infrastructure like routers and switches, and they have a series of front-end servers and application servers, database servers, and storage servers. And they received a flurry of complaints one Sunday evening out of the blue. They started getting complaints. And clearly, at that point, you're faced with, where is the performance? What's causing the sudden flurry of complaints? And typically in these environments, there is lots of information available from these various agents, from NetFlow or from logs, from port counters. You can put agents on your applications. You can instrument your database. There's lots of ways to gather this information today, and lots of companies can strike let's say a multidisciplinary cross-functional team to go and look at this, and it takes quite a diverse set of skills to go and troubleshoot this, and it can take hours to get to the bottom of it. However, our approach is not to do it that way. If you can instrument the network, whether it's virtual or physical, you can look at all user transactions, and in this diagram you can see instrumenting at 5, 6, 7 places. So every transaction seen 6 or 7 times. And with that kind of level of instrumentation and that level of detail, you can quickly start to see is the performance in the network, in the access layer itself. So in this example, the customer is instrumented right at the front door of their hosted data center, and they can look at response times out to all the users accessing their service, and they can rule out, is it that access layer or not? And that's crucial to figure out, is the problem external to your service, or is it somewhere in the service itself? And the quicker you can get to the bottom of that, the quicker you can get to going deeper into your own infrastructure and having a look at ruling out, is it your switching or root network infrastructure layer itself? And what happened in this case is they quickly, by instrumenting close to their front-end servers and measuring things like HTTP response times, by looking at all the HTTP requests and responses in the payload of the network data, they saw some outliers earlier during the day, but they saw this dense period where all response times went to seconds for a space of a couple of hours late in the day. And as soon as you see that at the front-end server, the question then becomes, well, is it in the application servers? Is it in the database layer? Is it in the storage layer? And being able to instrument in the virtual infrastructure and the physical infrastructure to be able to quickly rule those areas out and pinpoint it to the front door of your front-end servers is quickly, this was done in a matter of minutes, to be honest. And once you have that, the area pinpointed, then you can start looking at other stats. For example, they quickly went to their, to a network layer stat. In this case, just look at the TCP connections, and they saw that there was all of a sudden the TCP connection counts went up from what was 5,000 up to 50,000 here. So they had a 10-fold increase in the number of concurrent connections. So it kind of starts to look like the connections to the front-end server aren't being cleaned out or dropped properly at this point. But then you go a little bit further and you can decode everything that's inside these customer transactions, and you can see the full payload of what host names are they interacting with, what URLs are they going to, and now you've narrowed it to a set of servers, to a set of potentially hosts, to a set of URLs, and now you've got the problem sort of container into a tight container, and you can hand it to the right person. In this case, you'd be handing it to the app ops person in charge of the front end servers, and everyone's happy with this. The network team has been able to rule out the network. The database and the storage team have quickly ruled out those, and all fingers are now pointing at exactly where the problem is, and the problem gets quickly resolved. And this works quite well because now everybody's also working from the same set of data here. Everybody's looking at one tool measuring performance and for data, whether it's database performance or HTTP performance or storage performance. It's all coming from the network layer, and it's all being decoded and summarized and pointed at in one sort of tight view, and it just gets fingers pointing in the same direction, rather than a lot of finger pointing at, I think it might be the service provider, I think it might be the network, well, it might be the back end server. To be able to pinpoint the problem quickly it just facilitates communication really, really well. So what quickly becomes apparent in these type of when you want to instrument this level of instrumentation is that you need a scalable and cost-effective way to do it. It needs to work both in the physical area and in the virtual area. So and that's what Ixia has been presented, and that's why we work closely with Ixia to make this happen. We have a customer who's instrumented I think it's 120 points in their data center, and whether those are taps, if they're physical taps, instrumenting that can get you two outputs kind of, and can result in 240 ports of instrumentation, and all of that gets aggregated to what essentially is one Corval appliance that then can correlate and break that down from and discover it as database transactions, as storage transactions, as HTTP transactions, or as TCP connections, however you want to look at it. And so it's quite cost effective and scalable to be able to do that, even when you need to instrument hundreds of points in a single data center. So to give you a bit of background on Corval, we've been around in the enterprise space and the service provider space for the last 6 or 7 years. In the left column here is kind of tier 1 banks that we work with. We also work very closely with a lot of stock exchanges, and then we've branched out into service providers recently, and then we have some other kind of trading firms that are also using it, just to give you a flavor of some of our reference customers. So I guess I'll hand back to David or Keith.
Yeah, thank you, Ken and David. That was very enlightening. Let's move on to the question and answer section, as I see that there are several people asking for more information. Before we open it up to questions, I wanted to let everyone know that you can get free white papers for attending this webinar as well. As part of attending the webinar, you'll be getting an email that will give you links to both of the white papers featured here. In addition, talk to your Ixia representative about getting a free consultation and demonstration of our Phantom Virtual Tap product. It's one thing to talk about virtual taps, it's another to see what they can really do. In fact, we're offering a free 30-day trial of the Phantom Tap if you want to take us up on the offer. One last note, if you haven't seen it, Ixia has a network visibility blog where we talk all about different aspects of network visibility. This includes products, hot topics, future trends, and technologies that will be coming up in the marketplace, so check it out. Okay, let's look at all the questions that have been sent in. First one is, can you explain again what a virtual tap is? Maybe, David, that would be a good one for you.
Sure. So what the virtual tap is it's basically a pure software solution that installs the hypervisor kernel stack. There's two components. One is what we call the Phantom Manager, and that's just a management interface that connects and makes a sync to your vCenter. Once it makes it connect to vCenter, it gives you all the object inventories, information about your hosts, VMs, and IPs. The second part is actually the Phantom Btap module, and that's the monitoring piece that gets deployed into each individual hypervisor that you want to monitor. And like I mentioned on the slide before, it sits in between the virtual machine and the virtual switch, allowing you to get the out-of-band visibility to mirror the network packets of interest. And we're able to forward those packets back up to the physical wire to any existing monitoring tool of choice.
Okay. And then David, looks like another one for you here. Do I need a dedicated uplink to the packet broker from the host?
So there's two ways. Best practice is, of course, we always want to have a dedicated VNIC, a physical uplink that we want to mirror that traffic out of to optimize your existing VM port group. One thing to consider, if you have 40 VMs and you have all your mirror traffic going out the same vSwitch, you potentially double the amount of traffic that goes there. So we want to separate the VM production port group traffic and your mirror traffic.
Okay, and then David got another one for you here. So does the Btap export the captured vSwitch traffic via a physical Ethernet port on the hypervisor, which is then plugged into the NPB? Or are there other ways to get the traffic from the virtual environment to the NPB?
So yes, so the way it is your ESX host is going to be connected to a core switch, which then is connected to any NPB. So we actually capture the traffic passing between the virtual machines. Remember when I mentioned our capture policies are VM-based. So we'll actually look at the L2 to L4 network packets between the VMs and applications, and we'll export that out to a dedicated physical uplink into any NPB or directly into a monitoring tool, Corval, for example. One of two ways that we export the traffic. We do encapsulation using GRE, general routing encapsulation, or we can forward it using a VLAN tag.
Okay. Ken, here is one for you. How much disk space is required for the Corville analytics? Does full packet capture need to occur before the analysis?
Yeah, good question. So all of our analysis is done in real time, and you actually don't have to capture any packets if you don't want to. And but to be honest, most of our customers do want to capture packets, and they love the packet data. So what we allow is either you capture the full packet, or you choose to capture maybe only packet headers, or you choose to capture some of the decoded contents depending on your appetite for capture. So some of our appliances, our 2U appliance comes with up to 60 terabytes of storage for packet capture. Some of them just say capture everything. I want the real-time analytics, but capture everything.
Okay. David, got another one here for you. Can the Phantom Vtap talk directly to a monitoring tool, or does the Vtap have to talk to a physical packet broker, which in turn talks to the monitoring tools directly?
Both. We support both deployments. Again, if you have one of the things that we send traffic to a network packet broker is because if you have multiple tools, just like the visibility architecture, we can send it to a single aggregation point where you can do additional filtering, load balancing, and to send traffic to all the different tools and hanging up the network. But if you have a single tool or just a couple tools within the network, we can actually set up a forwarding policy that sends the traffic directly to the tool.
Okay, and then here's a follow-up one. David, does the Phantom Vtap have any filtering and aggregation capabilities, or does it do a complete replication of the data?
So yes, so that's one of the key things. It allows you to have granularity to select traffic from different protocols, port numbers, IP addresses. One of the things is that the more you define, the more targeted the data you'll be able to mirror, and vice versa. On the Phantom Manager, the less you define on your capture policies, the more traffic you'll get.
Okay, Ken, here's a question for you. What is the maximum amount of throughput Corville can analyze? Is it 20 gigs?
Yeah, good question. So it depends on the analysis that you want to do, and it can be as much as 40 gigs because our top appliance has 4 10 gigabit ports. But if you're doing intense analysis and you need to sustain that, it can be as low as 5 to 10. So it does depend on the traffic types and analysis. There isn't a simple answer, to be honest. For example, if it's HTTPS traffic and it's all encrypted and we need to decrypt it, then it's going to be on the lower end of the scale. If it's an ASCII type encoding on the wire, the throughput can be really, really high.
Okay, thank you. David, looks like another one for you here. How does the Ixia Vtap compare to the vsphere 5.5 feature that is available now for port mirroring and traffic filtering?
So one of the key things is to use the port mirroring feature in VMware. It only works if you have the virtual distributed switch deployed. In order to get the VDS, you have to have the Enterprise Plus licensing, which is about 3 times the cost of your standard licensing cost. The way we differentiate is that we have filtering, and that's one of the key things. With so much traffic passing through your VMs and applications and cloud environment, again, if you need to look for separate, segregated data or specific types of traffic to your monitoring tool, Phantom allows you to extract only traffic of interest. One of the key things is that if your tools are running 1 gigs or 10 gigs, it could be easily oversaturated, oversubscribed, and dropping packets. So again, it doesn't allow you to react and see the traffic that you need in a meaningful way.
Okay, thank you. Ken, looks like another one here for you. With all these taps and data being gathered, aggregated, filtered, and streamed, how do you ensure that it does not impact your network or CPU resources where the Corville kernel plugins are implemented?
Yeah, so I think that there's a couple of things in there. One is maybe for David, is that when you put the phantom top on a kernel, I'll let him talk about the impact on the CPU there. I think he's got a good answer there. But if you're tapping your network, it's kind of done passively and out of band. So you tap the network and a copy of the packets come through an aggregation, through the Ixia aggregation device out to the Corville device to do the analytics, and there's zero impact on the network when you tap it. If you span it, then switches have some span limitations, but they're getting better and better and can span quite a lot of traffic, again with no impact on the networking layer itself. And maybe David, you can speak a little bit to the impact of the virtual tap in the kernel environment.
Yeah, so the impact actually happens at the host level. One of the key things is when you deploy your VM and applications, you have dedicated resource pools, virtual CPU, virtual RAM, but as we install at the kernel level, we never use any of the resources from the VM level. So some of the benchmark tests, we use about 2 to 4% of the overall host itself. And again, this is the resources that never get dedicated or reserved at the application or VM level. Number two, one of the key things is we allow the customer and user to define your own filtering and capture policies. And by deploying the virtual tap forwarding policies, according to our best practices, we separate the mirror traffic from your VM port groups. So that way we retain your virtual switching efficiency and throughput. That way we have your VM production traffic never goes through the mirror traffic path.
Okay, and then David, looks like another one for you. Is the functionality of the Phantom Btap the same? Basically, is it independent of the different hypervisors out there, or are there limitations for some of the different ones?
So with Phantom, the solution is going to be at kernel level all the way around. So we have partnerships and alliances with all the major hypervisor vendors, such as VMware, working with Microsoft and Citrix. So one of the key things is that we never install any services or agents at the VM or application layer.
Okay. And then another one, what's the difference between a tap or a span? I guess that goes to you, David.
So basically, if you think of a span port, those are what you have on your core switches. Span ports have a very low priority, and your switches are meant to direct traffic. When you create a span, you're copying all the traffic to be forwarded out a specific port number on your core switch. That creates a performance issue. If your switch gets oversubscribed, you lose the ability to use the span ports. And out of a port of 24, you might only have 2 to 3 ports that's available to use a span. What a tap does is that allows you to mirror traffic from a separate device. What we do is before the traffic goes from the source to destination, it goes into our tap appliance that we're able to mirror the traffic out and send it out to NPB. And again, we never put any extra load on your core switches, and it's never a security breach. For example, if somebody goes into a network data center and gets access to a span port, he now has information from all the traffic from all your networks and all your computers and applications.
Okay, and then a follow-on to that was very similar. I'm currently running my VMs in promiscuous mode. How is a virtual tap better or different than what I'm doing?
So promiscuous mode is a very big security concern. And as I mentioned, if you're running in a multi-tenancy environment or have different security policies for each department, with promiscuous mode, you're allowing all the packets to pass through the vSwitch. So for example, instead of when you have promiscuous mode disabled, it will block all the traffic that the host level is not intended to receive. But now with promiscuous mode enabled, traffic is going to go from VM to VM to VM. So now if you administrator deploys a VM that doesn't have the right security policies in place, that could get breached. And one thing about virtualization and promiscuous mode is that if you have one layer breach, now you have access to everything else. Some of the key things, if you want to look at extremes, if you have DRS, which is a dynamic resource scheduler configured, it will automatically migrate your VMs to another host or another data center that has less resources being run. So in terms of attacks and breaches on a particular host, you'll see the resources running high with promiscuous mode, so you'll automatically move those VMs to another host. And now the host at a different location could be possibly breached with all that attack traffic that got sent through from the promiscuous mode from the previous location.
Okay, thank you. And then Ken, looks like I got a couple that came in for you. For in-house built applications, how does Corville analyze performance from capturing packets? Can these applications be decoded?
Yeah, in many customer environments, there's lots of in-house or proprietary applications, and they're communicating, over the network just like any other application, and their protocol is dependent on the internal spec. And so for that, we offer a couple of solutions. Sometimes we write a decoder to get you the analytics you need and provide it to you with our solution, or we also have an SDK to allow you to write it yourself. And there are some, clients such as maybe in the electronic trading community or in the government community where they don't want to share their proprietary, specs with us. And so the SDK allows them to unlock the power of their network data themselves without sharing any information with a vendor like Corville.
Okay, and then here was the second one. Can a user transaction be tracked hop by hop across multiple processing steps such as the database and storage? Yeah,
so that's interesting as well, because there can be enough information in the packets to identify that this HTTP request triggers this database transaction, which then triggered this storage lookup. And so when you're seeing a problem from the user's perspective, you can quickly pick up their transaction on the edge and then track it hop by hop across these systems throughout your environment. And a lot of people are not aware that kind of tying together can actually be done from network data, and that's what Corville Analytics do. It can be very difficult to do by hand if you just capture packets and use something like Wireshark. So we've invested quite heavily in that area.
Oh, okay, thank you. Looks like we're getting a little short on time. There was another question here for you, David. Can you say anything about the Phantom Tap support for ESX 6?
So right now we haven't scoped out support for ESX 6 yet. One thing is still in beta, but definitely that is on the roadmap, and once it goes GA, we'll continue to have support for ESX 6. But again, that won't be something until 2015. One of the things is that Ixia is an elite technology alliance partner with VMware, so we're partnered up to make sure that we have right access to the APIs that allows you to provide a joint solution together.
Okay. And then Ken, looks like we'll give you the last question since we're running out of time. Can you measure the performance across server provider links between the data centers with Corville?
Yeah, so Corville uniquely has the ability to essentially self-synchronize our appliances in a distributed environment like that. And what that allows you to do is measure one-way latency, loss, and jitter across the service provider link. And so all packets going from data center A to data center B, you can look at the performance from A to B, and you can look at the performance from B to A for 100% of the packets. And what that allows you to do is, as soon as there's a performance challenge, you can isolate that link and have a look at it and say, is there latency, loss, or jitter on that link that's impacting my applications or not? And if you can point it and say, yeah, the problem is in the service provider, then you know who to call. And if you can quickly rule the service provider out, then you know to go internally into your data centers quite quickly.
Okay, great. Well, thank you everyone for attending. It looks like we're out of time here, so we appreciate your time and attending, and hopefully you found this useful. Please let us know if you have any further questions or comments. You can contact Ixia or Corville. Thank you, and have a good day.